reproducible science are what are called analysis notebooks. So the idea of an analysis notebook comes from this idea by Donald Knuth of literate programming. And when we're coding, it's often good to sort of leave comments about what a particular bit of code does. But Knuth's idea was that we should sort of reverse that the comment, the description of what you're trying to achieve should sort of be the focus. And then only secondarily, the code is kind of the support of that. So what a analysis notebook lets you do is it lets you mix together documentation, description, code, and output into a single document. So here, sort of, a little bit of code, a summary of what's been done, some more code, some plot outputs, all in a single document. So the point of Analysis Notebook is to record analytic decisions. It's sort of a complete list of all the codes and commands you need if you need to revise or rerun anything. It makes it easier to collaborate because you're sort of describing, exactly what you're trying to achieve in a given analysis. It's a good reference for when you are writing up your manuscript because, oh, why did you sort of have a paragraph description of all of the cutoffs and, reasonings behind different decisions. And it also gives you a good starting place for future projects. So so we're sort of focused on this, reproducing our data. So we've got the same data and the same analysis, and we just want to make sure that we can get the same result with those two inputs being the same. So there's sort of a hierarchy of needs for analysis notebooks. So the most important thing that you want to have in here is a description of the analytic decisions that you've been making. On top of that is sort of a complete list of all of the code, the shell commands, the parameters and inputs to reproduce your analysis. Ideally, the notebook would sort of have in it as well all of the data that the project is based on. And at the top of this is sort of that the entire computing environment that you have is reproducible. So you're using exactly the same version of R and of all the libraries in Python that sort of originally went into your project. Hopefully, at least in your analysis files, you're already at least having some, common description of what you're doing. The minimum that you want to aim for is to include all of the codes and shell commands for your analysis. When working on genetic data, there are usually restrictions on sharing it. So this is kind of, an ideal that is normally, not really, maybe not something we'll ever be able to achieve. And then reproducible environments are also, don't worry about that until you have the basics down. So for analysis notebooks, there are two main sort of technologies. One is called R Markdown. As the name suggests, this is mostly based on R. The other is called Jupyter. That's more of a Python-based system. But both R Markdown and Jupyter can work with multiple languages. So you can put Python code in R Markdown and you can put R code in Jupyter. The bigger difference is that R Markdown's a plain text format, whereas Jupyter is sort of a rich notebook that runs in a web server on your computer. If you've ever used Mathematica or MATLAB, then Jupyter will feel really familiar. The other really nice feature of Jupyter is that GitHub can display them natively. So if you're mostly GitHub based, then maybe Jupyter can be a good solution. So just to show you what R Markdown looks like, it's based on this blog formatting syntax called Markdown. And the idea is that the plain text in the document should sort of be, readable the way that you'd mark up, say if you're doing a plain text email. So if you have like asterisks around something, that means it's bold, for instance. And in an R Markdown notebook, anything within these backticks and curly braces will be code. So when this is run, anything within these blocks will automatically be interpreted as R code. So here I have an example on the left of a really simple analysis notebook, and R Markdown will render that into an HTML file. So you see that 1 + 1 gets printed, and then the answer is also output. And anything that's a plot will come up visually within the document. So R Markdown, so that was an R Markdown document. There's also what's called an R Markdown notebook. And if you're using a notebook within RStudio, then code automatically gets sort of output inline as well as plots. So it's a little bit more of an interactive thing. So this, if you're sort of just playing around, this is a good way to get started, because it'll immediately output the result of any code that you want to execute. In an R Markdown notebook or document, you can also put shell commands. So anything within an R will get sort of marked with R will be interpreted as R code. If you put bash in there, then that will get called out to a terminal. So if you're doing like a Plink analysis, you can put that in there as well. However, it's also important that you might have a lot of shell commands you want to document. We don't want them to run every single time. So something like if you're doing a GWAS that could take 20 minutes or 3 hours or something, you don't want that necessarily to run every time you update your document. So you can use this at $= false so it'll read that in and print it out, but it won't actually execute it. I also showed you the example before of turning a notebook into a website. So on GitHub, if you go to the repository settings, then you can turn on GitHub Pages, and anything that's an HTML page, like a rendered notebook, can be viewed. Okay, so I'll stop there for sort of the main part of the presentation, and I'll, I guess, take any questions about that now. And after that, I can do a live demonstration of a few more of the features of Git and GitHub.
Great. So just to say again, if you can use the chat box, you can raise your hand, or you can actually click the Q&A button as well. So can I ask you a quick question, Mark?
Yeah.
So how long did it take you to learn these packages before they started doing something for you? So did you start learning them and then the payback came much later, or did you start to find them useful almost as soon as you started using them?
Yeah, well, I guess I started using them at different times. So I've been using Git version control just with basic R documents for a while. And the main reason I was using it was actually for that, being able to send code between my local desktop and a remote compute cluster. Yeah, so I think just using it like that, you can kind of see an immediate benefit because you're not needing to track what changes have I made locally that aren't reflected on the cluster, or what changes that I make over there that aren't reflected locally. Git will keep track of that for you.
Okay, so that might be an application that people use on this call quite a lot. Quite a lot of
Yeah,
people are working on their local systems, but also working on Eddy or on other servers. So
right.
that seems, yeah, that seems a really strong justification.
Yeah, or even if you have, a laptop and a desktop, and you want to keep code synced between them. Um, so it's better than something. So you could use Dropbox, for instance, for that same thing, keeping code synced. But Dropbox is, it has a little bit of a history that you can like go, you can go back to a previous version of a file, but you can't go back to the previous state that all a set of files were in easily in something like Dropbox.
Yeah. So
Whereas in GitHub you can say, 2 versions ago, I want to go back to that.
yeah. No, that makes sense. So there's a question coming from Pippa. Pippa, I'll read out your question for you. So, can you use R Markdown in basic R, or do you need to use R Studio? I'll ask your second part of your question in a moment.
Yeah, you can use R Markdown with just basic R. You don't need to use it in RStudio. So yeah, if I go to, yeah, let me make a new R Markdown doc, or actually just go to another project. Let me pull up that. Yeah, so here's that MDD symptom GWAS, so I could like open up this MDD symptoms just in a text editor. But I guess maybe Pip is asking about like the R GUI program. Yeah, it's actually a good question of whether that has any features for RStudio, or sorry, for R Markdown documents. But these RMD files are just plain text files. So what you can do in RStudio is just select the line that you want to run and sort of import that into the console, and then there's an R command that will do the compilation step.
Great. Sorry. So apologies for the dog. Pippa had a second part of a question. So she said, on GitHub, can you delete branches that you've decided were a dead end, or everything retained, or is everything?
Yeah, you can delete dead end branches.
Okay, and then we have a question on the Q&A from Laura Klinkhammer. Hi, Mark. Would you recommend learning using Git first, or go straight to learning GitHub?
I would, well, let's see. Hmm. I guess it depends on whether you, if one of your goals is to interact with Git on a system like Eddy, I would just try learning the command line Git tools locally. So if you go to the main Git website and go through that Git Pro book, and sort of follow the tutorials about create just with the command line like a new repository, just to learn those initial commands. It can be a good way to do it. But there's also not a problem with go to GitHub, create the repository, make a local copy, and then start. Here, my notebook's finally opened. Yeah, so just to go back to Pippa's question, this notebook is just a plain text file, so I could just copy and paste that code into an R terminal that way. But yeah, back to Laura's question. Yeah, I think it's fine just to sort of learn the basic Git commands. You know, just create a new folder, make a new project repository in it. You know, try making changes to files without worrying about the GitHub part of it.
Great. So I don't see any other questions at the moment. Would anybody like to raise their hand? Oh, there is another question. So Michael T, is there a good way to feedback on somebody else's code with GitHub?
There is an issues tracker on GitHub. So let's see if I pull up a window. Yeah, it's got this issues page, so you can, you know, so say if your student had their code on GitHub and they'd invited you as a collaborator, you know, you can make a new issue, and you can like tag it to a particular file or a particular change that they made, and then you know you could sort of have a suggestion of doing something, you know, that then the student could like reply with a comment to you, and then that becomes like sort of their to-do list for what to do on a project. So you could definitely use it in that way.
Okay, thanks, Mark. Any final questions from anyone, or would anybody like to raise their hand? No, I think we've come to a nice end. Thanks very much, Mark. That's as always extremely clear and very useful. And you said during the talk that you'd make the slides available to anybody that wanted them.
Mm-hmm.
Do you want to paste your? If people don't know, I think there are some people on the call who perhaps aren't from the group. So just do you want to paste your email address maybe in the chat box, and then people can scrape that and use
Yeah,
it.
sure.
If they want to get the slides from you. Okay, thanks everyone. So we'll wrap this up now. If there's another version of Mark's talk on YouTube as well. So this was so I thought we would show that today, but in fact Mark gave the talk again. But we can direct you to the presentation he's provided before if you'd like a bit longer to kind of look over and just absorb some of the things that he was saying on today's call. But thanks, Mark, and thanks for everybody who's dialed in today.
All right, thank you, everyone.
Bye-bye.